Our sun is the life-giving star at the center of our solar system, providing the energy that makes life on Earth possible. Every plant, animal, and human depends on its warmth and light. But the sun is much more than just a steady source of energy. It's a dynamic, ever-changing ball of plasma. Despite its familiar glow, the sun is unpredictable and explosive. Violent eruptions on its surface can unleash powerful bursts of energy and radiation into space with little warning. These solar eruptions, known as coronal mass ejections, can send massive clouds of charged particles racing toward Earth at incredible speeds, what we call space weather. These events can unfold over millions of miles between the sun and our planet. When these storms reach Earth, they can disrupt satellites, interfere with GPS navigation, and interrupt global communications networks that we rely on every day. In extreme cases, they can even cause widespread power grid failures, plunging entire cities or regions into darkness and affecting millions of people. Astronauts working in space face serious radiation risks from these solar outbursts, which can threaten their health and safety during missions beyond Earth's protective atmosphere. That's why predicting when and how these storms will hit is crucial, not just for protecting technology, but also for safeguarding lives, both on Earth and in space. For years, scientists could only observe solar storms as they left the sun, and then again when they arrived at Earth. The vast region in between was a mystery, making it difficult to understand how these storms evolved on their journey. This blind spot made forecasting space weather extremely challenging, leaving us vulnerable to sudden and severe solar events. To truly protect ourselves, we need to track these storms from their birth at the sun all the way to their impact on Earth, following their every move across the vastness of space. Enter NASA's Punch mission, designed to give us a continuous panoramic view of the space between the sun and Earth for the first time in history. Punch will help us see how solar storms travel and change as they move through space. With Punch, we're finally closing the gap in our understanding of space weather, opening a new era of forecasting and protection for our technology, our astronauts, and our way of life. Punch stands for Polarimeter to unify the corona and heliosphere, a team of 4 suitcase-sized satellites working together in perfect harmony. These satellites, each no bigger than a carry-on bag, are on a mission to unlock the mysteries of our sun and the vast space between it and Earth. Think of them as cosmic photographers, capturing the sun's activity from different angles, snapping images of solar storms and the ever-changing solar wind. Their unique vantage points allow them to see what no single satellite could ever capture alone. One satellite, the Narrow Field Imager, UNify, uses a special instrument called a coronagraph to block the sun's blinding glare. This lets it observe the faint, wispy outer atmosphere, known as the corona, where powerful solar storms are born and begin their journey into space. The other 3 satellites, called Wide Field Imagers, WFIs, are designed to scan a much larger area of space. They track solar storms as they erupt from the sun and race outward, following their progress as they travel millions of miles toward Earth and beyond. Each WFI covers a different slice of the sky, and when their images are combined, they create a seamless, panoramic view, stretching all the way from the sun's corona to the edge of Earth's orbit. This overlapping coverage ensures that no detail is missed as solar storms unfold. This setup gives us, for the first time, a continuous, 3-dimensional view of solar storms from their explosive birth to their arrival at Earth. Scientists can now watch these storms evolve, twist, and interact with the solar wind in real time. It's like a relay race in space. The UNify catches the initial eruption, then hands off the baton to the WFIs, which follow the storm's journey across the solar system, tracking every twist and turn along the way. For the first time ever, scientists can track a single solar event from its explosive start on the sun all the way to its impact near Earth. This unprecedented capability is transforming how we study and understand space weather. This complete, unbroken picture is the key to understanding and predicting the full life cycle of space weather. With this knowledge, we can better protect satellites, astronauts, and even power grids on Earth from the sun's unpredictable outbursts. Punch's innovative approach is revolutionizing how we watch our star, giving us new tools to forecast solar storms and safeguard our technology. The mission's teamwork is unlocking secrets of the sun we've never seen before, opening a new era of discovery and protection for our planet. Launching Punch was a carefully choreographed mission. On March 11, 2025, 4 Punch satellites rode a SpaceX Falcon 9 rocket into space, sharing the ride with NASA's Sphere-X mission. After reaching orbit, each satellite was deployed one by one, beginning their solo journeys. Mission Control quickly established contact, confirming all 4 were healthy and ready. Their destination, a special Terminator orbit, following the line between day and night on Earth. Each satellite used its own propulsion to maneuver into this unique formation over several months. By August 7, 2025, all 4 satellites were in place, ready to begin their mission. This orbit lets them constantly observe the Sun and the space between it and Earth, without Earth ever blocking their view. From this vantage point, Punch can watch the Sun's every move, uninterrupted. The stage was set for a new era in solar observation. Punch's real breakthrough is its ability to see the Sun's activity in 3 dimensions. Previously, we could only view solar storms from Earth's perspective, like looking at a cloud with one eye. Punch's 4 satellites spread out in orbit, each see the Sun and solar wind from a different angle. The UNify focuses on the Sun's inner corona, while the WFIs capture the surrounding space. Their overlapping fields of view are stitched together into a massive, seamless mosaic. This technique, called stereoscopy, lets scientists reconstruct the true 3D shape and movement of solar storms. For storms heading toward Earth, this is critical. We can now measure their speed, direction, and structure with unprecedented accuracy. Instead of guessing, we can forecast when and how a storm will hit. Punch's 3D vision is transforming our ability to predict space weather. It's a game changer for both science and safety. Punch's main targets are coronal mass ejections, or CMEs, some of the most powerful and dramatic explosions in the solar system. These immense bursts of energy and matter are not only visually spectacular, but they also have a profound impact on our space environment. CMEs erupt when the Sun's tangled magnetic fields suddenly snap and realign, releasing an enormous amount of energy. This process launches billions of tons of superheated plasma into space at speeds that can reach millions of kilometers per hour, creating a shockwave that ripples through the solar system. These explosive events drive the most severe space weather, generating powerful shock waves and dangerous radiation storms that can disrupt satellites, power grids, and even pose risks to astronauts in orbit. Before Punch, our view of CMEs was limited. We could only observe them as they erupted from the Sun, and then again as they arrived at Earth, leaving their journey through space largely hidden and mysterious. This lack of information made forecasting their impact on our planet extremely difficult and often unreliable, leaving us vulnerable to sudden space weather events. Punch changes everything by providing continuous, detailed tracking of CMEs as they travel from the Sun all the way to Earth, filling in the crucial gaps in our understanding. For the first time, scientists can now watch as a CME expands, twists, and interacts with the ever-changing solar wind in real time, revealing the complex dynamics of these solar storms. They can measure the density and magnetic structure of a CME, key factors that determine how it will affect Earth's magnetic field and our technology. This isn't just about watching storms unfold, it's about unlocking the fundamental physics behind these powerful solar eruptions and understanding how they evolve as they travel through space. With the data from Punch, we're building better, more reliable models for space weather prediction, helping to protect our technology and infrastructure from solar threats. The Punch mission is unlocking the secrets of the Sun's most violent outbursts, bringing us closer than ever to understanding and predicting the awesome power of our star. Just months after launch, Punch began sending back stunning images of the Sun's environment. In June 2025, it captured a detailed view of a CME erupting from the corona, wowing scientists at the American Astronomical Society. By August, NASA released videos showing CMEs blooming and evolving as they crossed the solar system. For the first time, we could watch the entire journey, not just the start and finish. Punch's images were stitched into seamless panoramas, revealing the complex structure of solar storms. The mission also produced the first direct maps of magnetic fields in interplanetary space using polarimetry. These early results are already changing how we understand the space between planets. Punch's discoveries are just beginning, promising even more breakthroughs ahead. Seeing the sun in 3 dimensions is a leap forward for solar science and space weather forecasting. For decades, forecasters struggled with limited, one-dimensional data. Punch's 3D perspective finally gives us the situational awareness we need. Scientists can now map the sun's complex corona and solar wind, tracing tangled magnetic fields and particle flows. This allows for more accurate predictions of when and how solar storms will hit Earth. Punch's data also connects ground-based telescopes, like the Daniel K. Inouye Solar Telescope, with space-based observations. By combining these views, we get a complete end-to-end picture of space weather. This holistic approach is unlocking the sun's deepest mysteries. Punch is not just advancing science, it's making our technology and astronauts safer. The mission marks a new era in understanding our star. Punch's ultimate goal is to protect our technology-dependent world from solar storms. A major event today could cause massive economic damage and widespread blackouts. Punch acts as an early warning system, giving satellite operators, power grids, and airlines time to prepare. For astronauts venturing beyond Earth, Punch's real-time tracking is critical for safety. The mission's data is shared worldwide, accelerating discovery and improving forecasts everywhere. By providing continuous, high-quality data, Punch is building the foundation for next-generation space weather prediction. It's a vital investment in our technological resilience. With Punch, we're better prepared for whatever our star throws at us. The mission is safeguarding our future in space and on Earth. Punch's 2-year mission is just the start of a new era in solar exploration. Its 3D data will fuel discoveries for years, refining our models and deepening our understanding of the sun. Future missions could expand on Punch's success, deploying more satellites for even broader coverage. A global network could one day provide space weather forecasts for Mars and beyond. Punch proves that coordinated multi-mission strategies are the future of solar science. These missions do more than protect technology. They answer fundamental questions about our place in the universe. As Punch continues its watch, it will reveal surprises we can't yet imagine. It's a testament to human curiosity and ingenuity, helping us understand our star and secure our future among the planets.